I think we should wait for a little bit.
Hello, how are you?
Hi, pretty good. How are you?
Good. Wait, you don't mind if we name drop you, do you?
Wait, name
Have you
drop?
answered some autonomous questions?
Uh, sure.
Should we start at MIT time?
I think so.
Should we start at MIT time?
I think so.
Should we start at MIT time? All right, I think we'll go ahead and get started. Thank you
That's
guys for being here tonight, and welcome to your second day of Hack MIT Blueprint. So we're MIT Motorsports. We're an Edgerton Center Club here on campus, so the largest build team actually. And I think let's go ahead and just get started with a round of introductions. I'm Kate, I'm the business lead.
I'm Kayla. I'm a business member.
We are also on business team. And Mackie.
I'm Trevor. I'm on Mechie Structures and specializing in composites.
Hi, my name is Vedant. I'm also a Mechie and business team member.
Awesome. We try to get a spread of majors here for you today. So I think to kick things off, let's just get started with one of our awesome hype videos from last year.
too. 10 more reasons why I need somebody new, just like you. Far more shocking than anything I ever knew. Right on cue.
All right. So that was just a little bit about our team. We know you're online today, but hopefully this helps you bring you into our shop. Oh no, it's repeating. Okay, so a little bit about the team. Every year we build a fully electric F1 style race car. So if we have any F1 fans out there, feel free, drop your favorite team in the chat. One of our members will be answering questions all night. And we actually are fantastic because we have a 1-year design cycle. So everything you see here, built, constructed in 1 full year. So we really have a fast turnaround. Every member has a very important key project. And everything is custom designed in-house. So what you see is student made, student built. And that's been occurring since 2001. And in 2013, we went from internal combustion, so gas, and we finally made the transition to electric. And because we went electric, we can do so many more cool things, which you'll hear all about tonight. And then we are a very accomplished team as well. We actually placed 5th at FSE Hybrid, which is a national and global competition. We have teams competing from all over the world. And we're also 23rd at Michigan. And you'll see these tracks are huge, but just some more fun car footage. But actually, that's part of the fun. When you join MIT Motorsports, you get to see this car live on the grid all the time. And so this happens twice a year. We compete in hybrid, which is one of our smaller competitions. It's in New Hampshire. So if you do join the team, you get a nice week-long break from school. And we also compete at Formula SAE in Michigan. So just think actual NASCAR tracks. You're there on the pavement, all around. And this actually occurs during June. So you can spend time with your friends during the summer as well. And then we'll have Kayla speak a little bit about our competition events.
Yeah, so each competition is broken down into dynamic and static events. Dynamic are the races. So there's 4 main races. Acceleration, you can just imagine a straight 75-meter road. And then skid pad, it's 2 big circles and it's testing your grip and cornering of the car. See how fast you can move around those circles. And then autocross is 1 lap, which is 1 kilometer long. And then we do endurance for 22 laps. And for hybrid in New Hampshire, it's 44 laps. And then some of our static events, design event, this is where the judges grade our car. We do a little introduction about the car and they'll question us why we built it this way. We did pretty good on that usually. And then our cost event, they basically try to calculate how much this car would cost if we made limited production of it. And then we are also doing business presentation and project management presentation. And then some of our team goals, we want to build a 4-wheel drive car this year. We're optimizing mass, thermals, vehicle dynamics, and controls. And then our dynamic events, our top finishes so far, we've done 3.9 seconds in acceleration, which is the 75-meter path, 4.5 seconds in skid pad, 48 seconds in autocross, and 1,600 seconds in endurance. As for our static events, we did have a winning design at hybrid last year. Our design finalists was, we made 110 points out of 150. And then our cost event, we placed top 10. And then we were our business event was our finalist. And then as for team structure, our captain is Eric. And then we have some main sub-teams, which include structures, energetics, EE, and software and autonomous. And then we have some extended sub-teams. These include race performance, our recruitment team, our simulations team, testing, and our business team. And as you can see, structures and energetics, software EE, they have many other sub-projects, sub-teams. Yes.
But we know you guys are part of Hack MIT. You're very interested in software. But we're going to run through our mechanical engineering side a little bit first, and then we'll come back and we'll talk about software and autonomous. So we'll have Trevor kick it off with a little introduction about what our mechanical engineering sub-team does here.
Yeah, so like Kay said, I know you are probably mostly interested in the software side of things, so I'll keep this brief. But I truly think if you're on a college team, whether it be at MIT or any other school, if you have the option to do something like Formula SAE, it is really the coolest like mechanical engineering club that you'll have the opportunity to experience, because every single part on our car is fully custom designed and built all within the course of 1 year. So some of our sub teams include aerodynamics, frame, suspension, cockpit, right? Everything fully custom built in house. Each part that you see on the car has like a spreadsheet of calculations behind the structures of it. A full set of like design reviews and analysis that goes into it. It's really like a full engineering design process that we do to work through some of these parts. You can see some of these photos here of our rear powertrain from last year, wheel packages, the carbon fiber cockpit, all the anodization we do, the frame welding, all of it is done in house. And yeah, it's a lot of fun. So that's just kind of the structure side of things. The other part of MECI is energetics. So if you want to switch slides, yeah. So even our battery is custom designed in house. It has a bunch of different modules filled with hundreds of cells and a custom water cooled loop. Our motors this year we made the big switch to 4-wheel drive, so we have full custom cooling for those motors, and then all of our electrical boxes are custom designed to be waterproofed, and all these different kind of things. So it's a lot of fun. There's something for anybody who's interested in MECI. You'll find something on a Formula team that interests you. Moving on to the next slide. A big part of it is also simulations, which is a lot more software based, but also dynamics and controls. So understanding how a race car performs on the track is a really complicated challenge, and is one of the one of the parts where you can see the most performance gains is really understanding how the car moves and being able to simulate it, so you can get a better idea of the loads your car is experiencing, how you can make it lighter, and how you can make it perform well on the track. So we do all kinds of MATLAB simulations to kind of gauge some of this stuff, so we can, and then at the end of the year, we compare our simulations to actual real world data that we collect on the track. And it's always cool to see how your simulations worked well and some areas for improvement. So that's kind of the MECI sim side of things for those of you who are interested. So thanks.
And then our next set of things actually is electronics engineering. So you have the EE. And I don't know if Vedant wants to speak a little bit more about this.
Sure, why not? Okay. So, another slide. So what's next? Oh no, it's just okay. It's just okay. So I'll talk a little bit about like our EE system. So our electronic system is kind of broken into two parts. We have what we call like the low voltage system and the high voltage system. You can pretty much consider our high voltage system to be what like runs the car itself, like so your motors pretty much, and it's like the interface between the battery and the motors. And we call it the high voltage system because we run it at 600 volts approximately. And to interface that with like the rest of the car and the rest of the system, we have a low voltage system. So that runs a lot of like our electronics, a lot of like our computing systems, a lot of like the smaller electronic subsystems that you see on the car. And the two systems have to be coupled so that they communicate with each other, which is a big project in itself. So that's like a bit about it. And then if you're interested in like our battery, we do our own battery in-house. We pretty much have cells that we buy off the shelf, and then couple them with like a cooling system and an electronic system to kind of interface all of that with the motors as well. And that's stuff that we do in-house. So if you're interested in that, there are definitely questions that you could ask if you're interested as well.
So the next set of things you're probably most interested in, this is software. And I don't know if Yibo wants to talk a little bit more about this.
Oh, software. So we have several sub teams in software. One is telemetry. Basically, we are making the software of all the parameters or data we're going to show in the car for the drivers. Like the temperature or something like that. And we also have firmware and control. Control is mostly like PID control. We write a software for the driver to better control the car and do testing. Like, what's the best strategy? You can race the car the fastest. Do we have an autonomous slide?
Yes, we do. And we have a fun video to go along with it.
Yeah, great. We can.
So this is a little bit about what we hope to accomplish this year. Actually, what's new to our competition is the autonomous component. So just imagine our car, which was previously driven by an actual driver, except now it's being replaced by an Ouster OS1 sensor, a LiDAR sensor. We're hoping to also implement some cameras to help with state and perception mapping. So ideally, the goal is we have the car fully driving by itself. It senses cones of different colors and it tries to navigate its way in between that. And this is amazing because it's happening not only within split seconds, but also you're moving at such a high speed. So it's really, well, it's truly revolutionary. And what we want to emphasize is that you don't have to be a PhD in order to develop an autonomous car. We believe the best way to learn how to do these is by doing it. So just in your first moments here, you learn how to build an autonomous car by building an autonomous car. We'll move on to some of our other slides. Business is also one of the major things we do here. And yes, we host webinars, but we also do tons of other fun things. This past weekend, we were able to go to the Red Bull snowboarding event because we're actually sponsored by Red Bull. You'll notice over here in the top left, they actually come to our campus with their rally cars. And if you ever do come visit our shop, which we hope if you come visit MIT campus, please find us. We'll give you free Red Bull. And in the bottom left, you can see a Lamborghini. We get invited to many cool car companies. We actually have partnerships with Ferrari, Tesla, Rivian, GM, Ford, hopefully Lamborghini in the future. It's just one of the fun things. We also manage sponsorships. Building a car is great, but me personally, raising the money is even better. So this is what I love about business team. We get to be the engagement side. But we also have a great testing. So I'm actually going to pawn you off again to Veer, who is one of our drivers, to talk a little bit about the testing process for cars.
Yeah, I think we have a video. Yeah, so this video is actually from FSA Michigan during endurance. And so basically for testing, what the testing team does is that they would have drivers and relevant people to what that testing trip needs go and collect data. And it's typically on the weekends, so it's not really interfering with classes. Rarely is it going to be on weekdays unless it's like right before comp and you need to get some data on the car. But it is typically an all-day thing. You'll have drivers go out early in the morning, 7 a.m., come back right before or like right during dusk when the sun's setting, just trying to get a full day of data in so that people like how Trevor was talking about sims, they can correlate to their data, and that our vehicle dynamics team can tune their setup and just make the car faster. Yeah, and then going more into driving, our main goals are to go fast, don't crash, and then if you are a driver on the team, you do have additional commitments. It's not that a driver on the team is only driving. For example, I'm actually a driver. I also do mechie and business. But it's in my opinion, it's the most fun part of the team. It's like very exhilarating. Really enjoy it.
So Veer and Vedant, what's it like driving a student-made race car?
Personally, having done a little bit of driving as well, an FSAE car, or at least specifically ours, is one of the fastest vehicles you could probably drive in certain aspects. The fact that it's student build just makes it all the more exciting, and the fact that we have like some influence on how it's being designed and how it's being built is also like one of those really rewarding things that you'd be like, when you're sitting and driving, it's like, wow, we built this thing, and it's one of those Like it's an experience that's not felt in many other places. So yeah, it's pretty amazing.
So as you're driving the car, computer scientists, all the aspiring ones out there, how can they make your life better as a driver?
So a lot of the stuff when it comes to driving is data. A lot of driving itself, while it is like a physical form, it is driven by data mostly. So we'll do a lot of telemetry and data collection, and based on that data, we can give input to the drivers and say that, okay, this is a corner that you're not driving fast enough, or you're not turning enough, or you're turning a little too much. And it's data like that, and numbers that we get from the car that drive the or pretty much drive the way we drive on the racetrack. And I guess one of the big things this year, I know we mentioned four-wheel drive, but I guess for those people that are really interested in software and controls, is our implementation of torque vectoring this year. So what that means is that we'll be taking information from the sensor in the car and where it is in space, and give the controls team, like that's the input that we put into the control system, and that will give us a measurement of how much force to drive each motor with, because what we want to do is always maximize grip on the racetrack, and torque vectoring kind of allows us to do that. But it's a very big controls heavy task that requires a lot of computing and a lot of math. So for people that are interested in that, that's a very big chunk of what's going to be going on this year.
We also have launch control, which is very fun. I don't know if Veer wants to talk a little bit more about that.
Yeah, so specifically in the acceleration event that Kayla was talking about earlier, is that the fastest way to finish Excel is to basically maximize your grip on startup. Going too fast, obviously, or not, maybe not obviously, but your tires are going to lose grip and just start spinning, and not going fast enough, you're not maximizing your time. So launch control helps us actually maximize power to the ground and grip, while in the startup phase, basically going from a stop to full speed as fast as possible. And that helps. That's part of traction control that helps the car overall maintain maximum grip without spinning out as much.
Awesome. So as you can see, the car is, yes, a lot of mechanical components, but there's a whole other side to it that's very computer science intensive. So if you do find an interest in this, please reach out to your Hack MIT coordinators. We'd love to get you guys implemented and hear your thoughts on the forward progress of our team. But I guess in terms of what does a typical timeline look for us? So typically we start designing over the summer while kids are at their internships. They'll probably be a little bit less engaged. But as soon as you get back on campus, the hustle restarts and we start designing things. I don't know if Trevor wants to talk a little bit more about the process of actually CADing a car.
Sure, yeah. So from a design standpoint, there's a big CAD element of it. So designing your parts prior to making them, but it's also a big kind of theoretical push from the simulation side and doing the calculations. That's one thing that I think FSA does as a program does a really good job of. When you're putting a driver in a car, you need to do absolutely everything to make sure that it's not going to break and that it's safe, as opposed to something that doesn't have a driver inside of it. There's much higher stakes. So we do a lot on the analysis side, FEA, hand calcs, big spreadsheets to make sure that our designs are safe. And we typically try to get all the design done before the end of the year, so that in the spring and the winter and spring we can really push for manufacturing and then get testing as soon as possible. Really, Veer was talking about a lot, and a lot of the performance comes from those testing trips and the time you have to tweak your car. So the earlier you can get your timeline done, the better. But it's a lot of fun, and yeah, it's something that I definitely recommend checking out when you go to college. So
awesome. Thanks, Trevor. In terms of where our team is right now, we actually just finished welding our frame. So in the next couple of weeks and months, you'll see us start rolling the car. We'll actually implement all of our electronic components and then implement telemetry. And then we'll start our major testing phase. So sorting out all the bugs, making sure that our driver can drive it how they would like it. We fine tune it for each of them. And then we'll start doing competition at both Hybrid and Michigan. So this is the end of our presentation, but we'd love if you guys stayed in contact with us. So please reach out to your Hack MIT coordinators. We also have an Instagram, MIT Motorsports. Feel free to follow along and see our progress as the season progresses. But good luck with the rest of your event and with team formation this evening. But thank you guys for attending.
Thank you. Thank you for contributing your time. Yeah, feel free to reach out to us if you have any questions. And yeah, thanks, Motorsport, to give such wonderful presentation. Yeah.